Hi, boys and girls. It's Mr. Battle here. What we're going to do is go through a little presentation on elements, compounds, and mixtures as we continue our discussion about matter. You're going to take some notes today. They are called Cornell Doodle Notes. And as we go through this video presentation, feel free to pause it if needed. And one thing I'm going to recommend is that you take your screen and split it. One thing you can do is wherever you're at right now on Zoom, as Zoom is open, you can click up top on the browser itself, and you'll notice on my screen, I'm using a laptop, but the same thing applies true to a MacBook or a Chromebook, whatever. And so you can grab what's up top and you can drag it to the side of the screen. You'll notice it gives you a half screen, and then you can take anything else you have open, click on that. For me, it automatically resizes it, but for you, maybe that's not the case. You can take whatever else is there and drag it to the other side, and then you'll have two split screens. That way you can see me on Zoom, my presentation. You can also follow along with whatever else we're going through, the notes we're going to take today. Okay, that's one good way of following along. Now, what I'm doing today, I'll be going through a presentation. You'll go through these slides here. There's not too many of them. You're going to fill out some notes on the slides themselves. It's interactive, and there are some tools that you can work with. And so you'll notice there's some tips here of what to do. And basically, some things you can do anytime there is a text box available, you can highlight all of the words in the text box. If you want to, you can use this highlight feature up top. You can change the color to blue. You can change it to transparent to get rid of that. You can even go up here to the fill color and just get rid of the colors in the box. You can fill it white. You can fill it lime green. You can fill it whatever color that stands out to you if you want. That only works for a text box. As you notice, when I click around, that option is not available. When I click on a text box, notice that it pops up. Okay, so that's there available for you if you want to on your notes. Most of what we do, we're going to type just in a text box and we'll drag and drop some options over there. Okay, but be aware there's all these nice colors you can use to highlight anything that you want, anything that you want to stand out. Pick one of those colors that works for you, and that's going to be a good way of highlighting things that make sense to you. If something is too small and you think, I can't see that, you can go ahead and click this text box, the font size, and you can change it to something that works for you. So pick something that makes it easy for you to see, something that is more convenient for you. Okay, so I will be going through my presentation. You will go through these slides and you'll fill them out. As you can see in these sort of fainted salmon colored boxes are things for you to do. Every row is going to be a topic you'll fill out. Okay, you'll follow along with me on the slideshow. If something goes too fast, you can pause it, rewind it. If something goes too slow, you can speed it up. I will have two links posted, one that will be from YouTube that you can adjust the speed, and the other one that's posted straight from my Google Drive account. That one, I don't know if you can adjust the speed, but you can play it just as normal in class. Okay, so I'm going to go ahead and make this one. I'll pull it over to the side. I'm going to pull them both together if I can and pull that up and follow that presentation. So let's take a look at our very beginning topic we're going to talk about today. And that topic is, how is matter classified based on its composition? So what you're going to do is, in your previous box that we had open, right here is an essential question you're going to type down. How is matter classified based on its composition? I'm going to go ahead and pull this up here into another slide to make that easier to see so you can follow along with exactly what I'm talking about. That way you can see the words on the screen. So as you can see, how is matter classified based on its composition? So this sentence here, you will type in your very first box up top, right up here. That's our essential question. How is matter classified based on its composition? As we look at matter, you'll notice there's all kinds of different types of matter we're going to learn about. And so we want to try to make sense of what is matter and what is the nature of matter. So let's take a look. Our very first topic question you're going to put in this box. Feel free to go ahead and delete the word type. We can get rid of that and start typing in that box right there. So our first topic question is, what is matter? What is matter? Now, by definition, and once again, you're typing in what is matter, you're going to follow along right up here where it says matter is. Matter is anything that has mass and takes up space. Those are the two qualifications for something to be considered matter. Has to take up mass. It means it's made out of stuff. It's made out of atoms, molecules, etc. It has to take up space. That is, it has volume. Those are the two qualifications for something to be considered what we call matter. Okay, so go ahead and type that in your box up here. Now for you, the next slide is I want you to type yes next to each item that you consider is matter. Then you'll take the line and cross off any item that is not matter. So get your text box ready. If you can see up here, you'll click on text box. And let's say that you feel like air is matter. I'll make a little text box here. I'll type in yes. And I want that to stand out a little bit. So I'm going to go ahead and fill that in with yellow. There we go. Now I have my text box. Once you get your crosshair over that, hit Control C from your keyboard, Control C. And now you have the option to hit Control V, and you can paste this text box wherever you want, multiple times. So you'll take a guess as air matter. If you say yes, that's fine. What else would you say is matter? Is light matter? Is energy matter? Is bacteria matter? Whatever you feel is matter, put that yes box over. You can hit Control V as many times as you want. Those will pop up. Whatever you feel is not matter, take these lines and go ahead and cross them out. Any item you feel is not matter, cross them out. So go ahead and take a moment and do that. What items do you feel are matter? Which items are not matter? So tell me, is air matter? Bacteria, magnetism, stars, ice, energy, or light? Go ahead and take a moment to answer those questions. Once you're done, you can unpause the video. Okay, so let's see how well you did. Air is matter. Yes, air is made of molecules and takes up space. It has mass. Bacteria, same thing, is matter. Magnetism is not matter. Stars, yes, they are matter. They're parts of hydrogen and helium burning bright in space. Gases that are being produced. Light itself is not matter. Electricity is not matter. And ice is matter. So let's take a look now at the next slide. As we look at topic number 2, here is our question. What is a pure substance? What is a pure substance? So down here in your topic 2 box, you're going to get rid of the word type and put in there, what is a pure substance? Now, as we learn about pure substances, how we define them, it's something that's the exact same all the way throughout. That is, when you cut it in half, you cut it in a third. When you break it, it's the exact same all the way throughout. So a pure substance is basically made of the same material through the entire portion of it, and it's anything that we can find on the periodic table. Now, pure substances are broken down by their physical properties and their chemical properties. So pure substances are made of the same material all the way throughout, the same properties all the way throughout. So you will go ahead and fill that in this box right here. Pause it if you need to. Physical properties. How do we describe what is something is a physical property versus a chemical property? Well, a physical property is anything that stays the same before it undergoes any kind of chemical reaction. So that is the way that something feels, how heavy it is, density, the melting point of a substance, the weight of something, the texture of something, how malleable it is, how flexible it is, how rigid it is. Those are all physical properties. Even to the appearance of something, as long as it's not changed, the color of something is a physical property. It's not the best one, but it is one, an example of physical property. It can change. It can change based on examples like chlorophyll in leaves. That's a different one, but that's one thing that is. A chemical property is something that we define that has to undergo a chemical reaction, has to go some kind of change, some kind of substance combining with another substance to make something happen. So, how does something react to an acid, to a base, to electricity, or I shouldn't say electricity, but to fire itself? How does something smell when it's basically burned or whatnot? Those are examples of chemical properties. How flammable it is and how acidic something is are all examples of chemical properties. So you should have those filled out in this box right here. Physical properties and chemical properties. So now, once again, pause the video if you need to. A good way to decide whether or not something that you're holding in your hand, we'll move on to the next slide, is to pretend like you're holding it in your hands. That is, if we're looking at a pure substance. So ask yourself if what you have in your hand is one kind of a substance. That is it all the same thing? If so, that is something that more than likely we can classify as a pure substance. Okay? Our next topic, topic number 3, is what is the simplest form of pure matter? So go ahead and type that in your next box. What is the simplest form of pure matter? Now, what I alluded to earlier, as I shared, were that elements are the purest form of matter, which cannot be broken down. These are anything that we can see classified on the periodic table. As you've seen these element names before. So anything, any amount of a element retains the unique physical and chemical properties of that element. So here we have our elements and what elements are. The purest form of matter, which cannot be broken down. Any amount of a pure element retains the unique physical and chemical properties of that element. So now you're going to notice we have some different symbols for elements. We're going to start to identify what those symbols are. So if you follow me to the next slide, we're not yet going to look at a periodic table, but we're going to try to make sense of what do we see on the periodic table. What are some elements that we know of? Okay, so on the right side, you'll notice that's what we're going to pick up here. Here's the periodic table, and we're going to pick up in this box where it talks about there are blank number of elements. And here we have it. There are 118 elements which are represented on the periodic table. Chemical symbols are 1 or 2 letters, but only the first letter is capitalized. And here we are. Chemical symbols are 1 or 2 letters, but only the first letter is capitalized. Okay. Now this next part, we're going to do this part together. We're going to identify all of these elements. We'll do that together, and you'll type in what are the answers to those elements. Some you may know already. Some you may not know. So the first one, as you can see, in no particular order, top left, C stands for carbon. C-A-R-B-O-N. Carbon. Carbon makes coal. Also, when carbon gets crushed over time, can form beautiful substance like diamonds. Sulfur, as you can see, is what the S stands for. That is sulfur, SULFUR. Sulfur has a yellow like substance. It has a rotten egg smell. It's kind of pungent. It's nothing that really is that attractive or something you want to be around. Helium, you're probably familiar with HE, helium. Helium is a gas that we put in balloons, as you know. It's also a gas that's very prevalent in stars out in space. Helium, HELIUM. Ne stands for neon. And once again, we're over here. Ne stands for neon. Neon is a gas. It's a very stable gas. It's very non-reactive. And that's why we see it in our signs for like pizza shops, parlors, for any kind of storefront sign. Very stable gas. When you run electricity through it, it's really bright and illuminated. Ca stands for calcium. CALCIUM. Fe stands for iron. IRON, iron. And capital M, lowercase g, stands for magnesium. MAGNESIUM, magnesium. If any of that was too fast, go ahead and rewind, go back. Okay, so let's go ahead and go down to our next one. Topic number 4. So part of this got cut off. You're going to see. Our question is, what is a diatomic element? Diatomic. The word di means two, and atomic is pertaining to the atom. So these are atoms that are basically two atoms put together. On the periodic table, you'll notice here we have twins. These two girls side by side. These elements like to combine in nature to create what's called a stable state. So diatomic atoms. So you're going to type in this box here. What is a diatomic element? What is a diatomic element? Diatomic, as you can see, means two atoms. And down below, a diatomic element is an element which in its purest form is always bonded to itself. Kind of like twins are bonded, always bonded together. Okay? Now, there are 7 diatomic elements that you're going to learn about. And I have it broken down here across your charts. And you'll notice that I have some filled out for you already, like iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. And you'll fill out the parts here as we go along. So take a look here. There's a mnemonic which we can use. This one is not a nice mnemonic, but it's something that does work, and it's true. The mnemonic goes like this. I have no bright or clever friends. And each letter stands for one of the elements of the periodic table. I for iodine, H for hydrogen, N for nitrogen, Br for bromine, O for oxygen, Cl for chlorine, and F for fluorine. So it's a mnemonic you can use if you want to keep in track the 7 different types of diatomic elements. So down here, you will put down up here, you'll spell out the mnemonic. I have no bright or clever friends right up top. We identified already some of them. Iodine is identified for you. Hydrogen is. What does N stand for? You'll type it in the box right here. Oxygen, and then F for fluorine. Okay. Our next topic we're going to look at is topic number 5, That is, what is matter that is composed of more than one element? What is matter that is composed of more than one element? So you'll fill that out here in this box. Yeah, the answer to that are compounds. Compounds are pure substances that are made of two or more elements, chemically bonded together. And you'll fill that out right here. Go back to it. Compounds are pure substances that are made of two or more elements chemically bonded together. A compound has different properties than the individual elements inside of it. Okay, so notice how we talked about elements up top. We had just basically one type of substance, one type. Now you're going to notice there are two that are combined, two or more that are combined into what we call a compound. So, energy must be taken in or given off when a compound is broken apart or put together. So, separating the elements in a compound requires a chemical reaction. Let's take a look. So, as I shared, compounds are pure substances that are made of two or more elements chemically bonded together. You'll fill that out right here in these boxes. And then we're going to pick up right down here in case you missed that. A compound has different properties than the individual element it is in. So next part to fill out, we're right down here where it says must. Energy must be taken in or given off when a compound is broken apart or put together. Separating the elements in a compound requires a chemical reaction. So as you can see over here in this beaker full of science, what are some things that would indicate a chemical reaction is taking place? As you can tell, that it has a thermometer in here. There's a temperature change. There's all kinds of bubbles being formed. Gases are given off. And there's indication of a different smell taking place. Some fumes are given off. All kinds of signs of a chemical reaction that's taking place. So next, what I'd like you to do is we're going to take a look at the chemical formulas themselves. And chemical formulas represent how many atoms of each element are a part of the compound. So you're going to see some circles and ovals at the very bottom of the screen. And what I want you to do is circle each element symbol with a different color in the chemical formula. So for example, we circled carbon with purple up here and oxygen with red. That makes up carbon dioxide. Over here, we circled calcium, carbon, and oxygen over here with three different colors. That is calcium carbonate. So on your slide over here, if you scroll down to the bottom, you'll see all of these rings are already made for you. Go to drag one, put it over the item you want, and circle all the different types of elements. Once you get it there, you can use your keypad to make it the spot you want it. But every atom, every different atom, give it a different color, like I showed you earlier. So, for example, carbon and oxygen are two different elements, so give them two different colors. Take a moment to do that. Feel free to pause the video as you do that and hit play once you're done. Okay. Hopefully you did fairly well. You have all of these items circled with different colors. Don't forget CA. If you see a lowercase letter, that is a different, the C and the A go together. Those two, you can make the box a little bit bigger so it goes around it. That fits that element. So now let's start to identify what are the names of some of these compounds you've seen. Some of them you may know already, like H2O. You can probably guess that's water. Then you see some things like C6H12O6 glucose, which is another name for sugar. So let's go and identify these compounds that you see going across your screen. H2O, as I said earlier, that's water. C6H12O6, that kind of C, it's basically a 1-2-1 formula. 1 part carbon, 2 parts hydrogen, 1 part oxygen. Those make up our sugar groups. They're kind of in that 1-to-1 ratio. Sugar. NaHCO3. Sodium bicarbonate is just another fancy word for baking soda. Baking soda. NaCl, sodium chloride, is what we call table salt. And if I skip the first ones, CO2 is carbon dioxide, and CaCO3, calcium carbonate, are what seashells are made of. On to topic number 6. So, what is matter that is composed of more than one substance? You're going to go down to topic number 6. In this box, type in our topic question. What is matter that is composed of more than one substance? We call those things mixtures. Simply mixtures. Here we are on what mixtures are. Mixtures are not pure substances. Their parts are not chemically combined. They are only physically combined. One classic and simple example of a mixture are looking at salads or types of cereals where you can easily distinguish the different parts of that substance. That's what we call a mixture. So here we are what mixtures are. They are not pure substances. Their parts are not chemically combined. They are only physically combined. When substances are combined into a mixture, they keep their own properties because a new substance has not been formed. We are right here. They keep their own properties because a new substance has not been formed. There are 2 types of mixtures we're going to learn about. We call a homogeneous mixture, which is the same throughout, and a heterogeneous mixture, which you can see the different parts throughout. 2 types of mixtures, heterogeneous mixture and homogeneous mixture. Homogeneous mixtures, the parts are evenly mixed and they stay evenly mixed. For any type of homogeneous mixture, the parts are evenly mixed and they stay evenly mixed. And so we look at things like iced tea or plus water, basically give you a nice sweet summer drink. Things like Gatorade, Powerade, etc. Drinks that are the same all the way throughout, you can see just one uniform substance are good examples of homogeneous mixtures. Air is another homogeneous mixture. These can also be called solutions. Solutions are basically just parts of solutes or powders, usually sugars or salts, etc., that get mixed into a liquid, and they're mixed so well that they look the same all the way throughout. Brass is a combination. It's an alloy basically of copper mixed with zinc, giving you the same material all the throughout. These are examples of homogeneous mixtures. Heterogeneous mixtures, the parts for a heterogeneous mixture, and here we are over here, the parts are not evenly mixed. They are not evenly mixed. Particles can be seen in a beam of light. So some examples of heterogeneous mixtures, things like soup. Now, you typically have to have things in your soup, not just the broth, but things like chicken noodle soup. We see the noodles, the carrots, whatever else would go in there, maybe parts of chicken, etc. Soups are good examples. Um, they can be what we call suspensions, which particles can settle and form layers over time. Good examples of that are things like different types of sauces that we put down. You always have to shake well. Things like salad dressing, or I should say more like ketchup. Ketchup's a better example. Salad dressings you can typically see, depends on the ones. You can see the parts between those ones. But yeah, you can see the oil separates from the actual liquid itself. Sometimes water is mixed in there as well. And then colloids. Milk is a good example of a colloid. Milk is made of fat plus water itself. And over time, it can separate into its different parts here. Okay, so topic number 7. We're in our final one here. What are the similarities and differences between elements, compounds, and mixtures? So, what I'd like you to do here is complete the triple Venn diagram that shows the similarities, differences between elements, compounds, and mixtures. So you'll notice the very bottom of your screen, don't forget to type in your question right here, the topic question. What are the similarities and differences between elements, compounds, and mixtures? So at the bottom of your screen, you're going to see all of these text boxes made for you already. And what I want you to do is go ahead and place them. Where do they fit in this Venn diagram? Anything that overlaps all 3 of them, go ahead and drop it in this middle box here. If it only overlaps the mixtures and the element portion, they will fit in this area. If they overlap the compound and the element spot, they'll fit right here. So go ahead and take any words down here and do your best. Just take your guess. Look back at your notes up here and drop these boxes where they belong. I'll pause the video. And once you're done doing that, you are on your final part, and that is for you to summarize basically everything we've just learned or looked over. You're going to use this concept map and drag and drop these words onto the concept map. So take a look that we know that matter is broken up into substances. So let's take a look what else matter is broken up into, okay? And you'll drag the other words to fit these boxes. We'll take a moment, pause, review that, and then I will help you out in just one moment. Okay, hopefully you're ready by now. Elements, matter is broken up into substances, and we're going to take the next word over here and drag it over, called mixtures. Drag over mixtures to fill this up here. As we learned earlier, there are 2 types of mixtures. You learn in your notes. And so use your guesses here, use your notes to fill out these types of mixtures. As you can see, we talked about homogeneous mixtures and heterogeneous mixtures. Now notice where the chart goes. As you can see that milk is in this column, so what kind of mixture would fit over there above milk? As we talked about earlier, we learned that heterogeneous was the type of mixture that fits into that category. So then we have, as we go down, what kind of substance is actually milk. So go ahead and fill out your flow chart. Use these terms here to the best of your ability. Identify all the parts down here. And when you're done, hit that turn in button. Okay? If you have questions, let me know. That is it for today. Thank you for being patient and going through this presentation. Feel free to review anything you missed. If you have questions, let me know.